Hi class, this is going to be a very quick video on the introduction to velocity versus time graphs. Way back in first semester, I think in the second chapter, we learned about graphs that were actually position versus time graphs, or distance versus time graphs. And what we learned was that if an object had a line that looked like this, that was going forwards at a constant speed, and an object like this was probably going at a constant speed but slower, and an object like this was going forward but going faster. And we learned some things like that if the line went straight up and then across, that it stopped, or if the line went up and then down, that meant that the object was going forwards and backwards. You're going to have to try to get that out of your head, because now these are velocity versus time graphs. So these graphs aren't showing where the object is going, it's just showing how fast it's going. So for example, let's say I'm driving in my car and I speed up. Well, I've got miles per hour here on my y-axis. So if I go forward and I speed up, maybe in the first second I'm going 10 miles an hour. And in the second I'm going 20 miles an hour, and 30 miles an hour, and 40 miles an hour. So every second I'm gaining 10 meters per second, or 10 miles per hour of speed. I would have a line that looks like this. So this would actually be me speeding up, because literally my velocity right here on the y-axis is going up. So this isn't me going forward at constant speed anymore, because this is a velocity graph. It is me literally speeding up in my car. Now if I buy a super fancy car, maybe in the first second I go 20 miles per hour in the first second, and then I'm going 40 miles per hour 1 second later, and 60 miles per hour a second later. Notice how the slope is much higher. But if I have a really terrible car, maybe I only go 5 miles per hour in a second, and then 10 miles per hour in 2 seconds, and 15 miles per hour in 3 seconds. And you can literally see the slope is lower. So the slope is going to tell you the acceleration of the car. So this is a very high acceleration right here for that car. And this car is an old beat up car that has a very low acceleration. So when it comes to velocity versus time graphs, the slope, I'll put a note right here for you guys, the slope is going to be the acceleration. So if you have a high slope, you have a high acceleration. And if you have a low slope, you have a low acceleration. And that's probably about a third of what you need to know right now. The last thing that you guys need to know, the last few things, is what happens when a car accelerates and then the line goes straight across. You may be thinking, oh, it's going forward and then it stops, but remember, this is accelerating, and this isn't stopping. It's got a speed. It has a velocity right there, which means this is actually a constant speed right there. It is moving. It is moving here at 30 meters per second. So this would be you speeding up in your car to 30 miles an hour and then staying at 30 miles an hour. Two more things. What if a line goes like this? In this case, the object's not going backwards. The object is still going forwards. We're going to keep all our objects going forwards for this chapter. What it's doing is it's going 50 miles an hour, then 40, then 30, then about 20, about 10, then not 0, which means this line that has a negative slope that goes down and to the right, this object is actually slowing down. So a line that goes down and to the right, whether it's got a high slope or a medium slope or a lower slope, those are all objects that are slowing down. With this object that's literally slamming on its brakes, it's really decelerating. Its angle, its slope is very high. The last thing I want to say about these graphs is what happens when you have an object that maybe goes forward and speeds up, maybe maintains a speed, slows down, and then this part right here, we'll focus on that. And you might say, like, what is that object doing? And you might say, oh, it's a constant speed, and that is true, it is at a constant speed. But if we move our line across, we look to see that that constant speed right here is 0. So any line that is on the x-axis is stopped. Okay, so we've gone over speeding up, we've gone over constant speed, we've gone over slowing down, which would be this region, and we've gone over stopped. Let's just do a couple quick examples, and then you guys can go to your homework sheet. This object right here, this first example on the left here, this would be an object that speeds up, then slows down, and this object slows down to a constant speed. So it's got some speed, whatever it is. I could make it up. Maybe it's 10 miles an hour. So it's speeding up, it's slowing down, then a constant speed. This object over here looks like it's slowing down, but it goes all the way down to the x-axis. And on the x-axis, right here, as you can see, is 0. So that is stopped. And then right here, you can see the object speeds up. I know it's a little challenging because we're used to the forwards, backwards, stopped from way back first semester, but just keep in mind that this is a velocity graph and it's not telling you where it's going, it's just telling you how quickly it speeds up, how quickly it slows down. It's just telling you how fast it's going, not where it's going. All right, that is the end of the video. Thank you.